Okay, so up to this point, we've been talking about how you can use a chemical equation in given quantities to figure out, well, if I have one, how much of the other do I need, or how much product should I make? Well, what if I have quantities for more than one reagent in a reaction that has more than one reagent? How do I know which one to use? We have to figure out which one is the limiting reagent. So here's the concept. Stay with me. If I have a big jar of peanut butter and an equally big jar of jelly, pick your favorite flavor if you like peanut butter and jelly, and if not, I don't know, pick some other analogy here. But I only have 2 pieces of bread. How many sandwiches can I make? Now don't get cute and say, well, I could like cut each piece of bread in half, or I could cut it into 4s, and I could do a few different things. But really, at the end of the day, only one standard size sandwich, okay? Because you only got 2 pieces of bread. So it doesn't matter how much peanut butter, how much jelly, you're going to have a bunch of that left over. You're only going to have one sandwich. The same idea applies in chemical reactions. If I have extra of one thing, at the end, I'm still going to have some of that left over. And the thing I have less of is going to get all used up. So if I have less of one reactant, but here's the thing, in terms of their molar relationships. So I have quantities in grams, usually. I have to figure out how many moles of each I have. And even then, I can't necessarily compare them mole to mole, because what if they're not a 1-to-1 ratio? If in the equation it's not 1-to-1, then I can't just look at the number of moles of each and say, oh, that's the smaller amount. That's what I'm going to run out of first. I have to do a little bit more math. So we have to figure out what's the bread as opposed to the peanut butter or the jelly. So here's an example. 10 grams of calcium chloride. I react that with 10 grams of silver nitrate, both of them dissolved in water. Then I combine those solutions. I'm going to get a precipitate. Silver chloride is going to precipitate out because silver chloride doesn't dissolve. There's the reaction. There's the balanced chemical equation. So some questions to ask that as we answer them, that's going to get us to figuring out what's the limiting reagent, and therefore which one do I choose to figure out how much silver chloride I'm going to get. So first of all, how many moles? I have grams. I need to convert to moles. But it's not just enough. I also have to look at what's the molar ratio of those 2 reactants. And finally, can I compare the moles that are given for each of them with the amount needed? So if I figure out the moles of of calcium chloride, and I say, well, how many moles of silver nitrate do I need to use all that up? And then the question becomes, well, do I have that? Do I have more than that? Do I have less than that? So let's do the math. There's the equation. And I'm starting with 10 grams each. And I want to know how much silver chloride I'm going to get out of this combination. So how many moles of each? Do the process. 10 grams. Divide by molar mass. And I get 0.9 moles of calcium chloride. Divide by the molar mass of silver nitrate. I have 0.0589 moles of silver nitrate. Then what I can do is take one of them and, using the molar ratio, convert it into the other to say, well, how much should I need? So 0.09 moles calcium chloride, well, it's a 2-to-1 ratio of silver nitrate to calcium chloride. So I need twice as much silver nitrate as I do calcium chloride. I'd need 0.180 moles of silver nitrate to use up all the calcium chloride. But as you see already, when I compare that to what I actually have, what I was given in the reaction, I don't have that. I'm going to run out of the silver nitrate first, because I have less than what I would need to go with all the calcium chloride I have. So I'm going to run out of AgNO3 first. That's my limiting reagent. That's the one I use then to figure out, well, how many grams of product will I get? So I look at the ratio. I say, okay, it's silver nitrate, so it's a 2-to-2, which means a 1-to-1 ratio in terms of moles. And then using the molar mass of silver chloride, I figure out I should get 8.44 grams of silver chloride. So one way to do this is to figure out how many moles of each you have on hand, and then pick one of them, use the molar ratio from the equation, and say, well, how many moles of the other should I have or do I need? And then compare it to what you actually have. That's one way of doing it. I'm going to show you an alternative way that you might find easier. So the alternate method is just to do the three-step stoich with each of the things you start with. So you do it twice, once for each of the reagents. And the smaller of the two final answers you get is the actual product amount, is your actual, as we'll learn very shortly, theoretical yield. And therefore the thing you start with to get that will be your limiting reagent. So let's see what that looks like. So here, if I do the 3 steps and calculate and take the 10 grams of calcium chloride and bring it all the way through, convert it to moles, use the molar ratio to the silver chloride, the product, and the molar mass of the silver chloride. If the calcium chloride was my limiting reagent, I should make 25.83 grams of silver chloride. As we already know, if we do the 3 steps based on the silver nitrate, I only get 8.44 grams of product. The smaller amount is the right amount. And what that means is that the silver nitrate is your limiting reagent. So if it's easier just to do the 3-step stoichiometry with each of the things, and then compare your answers, say, smaller answer, that's the right one. What I start with to get that smaller answer, that's the limiting reagent. So here's one for you to try. Get out your pencil, your paper, your calculator, your fingers, your toes, whatever you need to do to your math. Here's an example. 20 grams of silver sulfide and 16 grams of oxygen. It's going to react. There's your chemical equation. Lovely ratios, right? 4 to 15 to 2 to 8. So you can't just eyeball this one. You got to do math. You give this a try. Pause the video. Figure out which thing's the limiting reagent and how much sulfur trioxide you should get out of this. All right, did you pause it? Did you give it a try? Let's see how you did. So, going through the steps, convert each thing to moles. In my example, I converted the iron sulfide to oxygen, and lo and behold, when I compare these, turns out the oxygen is limiting because I have a half a mole, but to use up all the silver sulfide, I'd need more like 2/3 of a mole. Not quite 2/3 of a mole, 6.626 moles. So, using the oxygen and the ratio of sulfur trioxide to oxygen, and then converting to grams, I get 21.3 grams of sulfur trioxide. So let's talk a little bit about the term yield. Yield is how much product I should get. Theoretical? Well, that's kind of what we've been doing all along. It's what the math says we should get. But if you do it in a lab, if you do it in an actual real-world setting, you may or may not get all you're supposed to. So you have your real lab result. So then we calculate, well, what's the percent of what we should have gotten? How does our theoretical and our actual compare to our theoretical, I should say? And so it's the actual divided by the theoretical, and then to make it out of a percentage, we move the decimal over 2 places, multiply by 100. So here, I'm going to give you a chance to practice again. So here's a reaction, antimony sulfide and iron. If I react them, I'll get pure antimony and iron sulfide. And so I'm giving you 15 grams of the antimony sulfide and plenty of iron. So no limiting reagent here. I should say, you don't have to calculate it. The antimony sulfide is the limiting reagent because you have plenty of extra iron. And I'm telling you that when you do this in the lab, you collected 9.84 grams. That's your actual yield. So what's the percent yield? You have to do the 3-step stoichiometry to calculate your theoretical. And then actual divided by theoretical times 100. Grab that pencil and the calculator. Give it another try. Pause the video. Okay. To do it, let's check your answers. So, converting the antimony sulfide into moles, then it's a 2-to-1 ratio of antimony to antimony sulfide, and finally convert to grams. I should get, my theoretical yield is 10.76 grams. But I said in the lab you only got 9.84 grams. So that means your percent yield is 91.4%. Okay, so in this video we talked about limiting reagent and how to calculate it. And we also then talked about the different terms when we talk about the yield, the amount of product you get, what you calculate, and then in a real world setting what you get and how those two compare.